Okay, today's lab. We are going to be, what? We're going to be looking at how we can separate polymers. So I spent a good 15 minutes at home sorting through our recycles, and I could only find things that were in categories 1, 2, and 5 at home. Had lots of those things, but I didn't have the others. So then I went dumpster diving, and there's huge amounts of 1s, a lot of 2s, a fair amount of 5s. I found exactly one example of a 4, and one example, I think, of a 6, and one example of a 7. I didn't find any examples of polyvinyl chloride that people had put in the recycle bin. And so I have taken them, chopped them up here, and we are going to separate them based on their densities. Now, a few things about polymers and recycling. First, what is a polymer? It's a chain of atoms. A chain of atoms with carbon on the backbone. Why carbon? Well, you actually had a question on the test about why carbon. Carbon is the one that forms strong bonds with other carbons so you can make that chain. Remember in class we had the example of a sulfur ring. You just don't have other things that make rings very much like carbon does. You can make ozone is a ring with oxygen, 3 oxygens, but it's rare to have a ring with anything that's not carbon-based. So approximately 7% of recyclable plastics are recycled annually. It actually depends on which website you look at. I saw one that had a much higher value listed, but I think this is the accurate value. About 7% of recyclable plastics are actually recycled. There's 33.6, what was it, million pounds or billion pounds, a very large amount of plastics that we use. And most of them aren't recycled. What happens to them if they're not recycled?
They are thrown into landfill.
Into the landfill generally.
Yes.
Now, you find a lot of propaganda about recycling. Is recycling good or bad?
Good.
Good. Why is it good?
Because we're saving things from being thrown into the landfill.
Okay, saving things from being thrown to the landfill, what did you say? Okay, reusing stuff. What did you say? Yours was landfill?
We don't have to make as much stuff.
Okay, don't have to make as much stuff. Now, as I was looking through things, I wanted to get a balance. You'll notice the next to bottom thing on my list here. These days, it's actually, according to what I found, cheaper to synthesize new plastics than it is to recycle them. So it's more expensive to recycle. So it's not a money saver. In terms of energy, it is a bit of a saver. It takes less energy to recycle plastics than it takes to synthesize them. So the energy cost is lower for recycling. But the big primary reason why I choose to recycle is to keep from putting stuff in landfills, from putting stuff in the ocean so it can end up in that mid-ocean gyre, the big patch that has trash in it. And so that's why I recycle, is be taking care of the earth. Okay, so recycling saves the environment, which means a lot to me. May not to you. I'm not here to convince you of my way. The different recyclables, so I just have the 7 different categories of recyclable polymers. The first one is polyethylene terephthalate. Gotta like that word, terephthalate. This is what it looks like. Now notice it has brackets, and then it has something in between and an N. The N means you have a very large number of these in a chain. So you just take this whole structure and repeat it. Yes, then it goes and keeps going. So it has a very large number of those in a chain. So the polymer is the fact that we just took this unit and repeated it over and over and over to make a very long chain. Our DNA is a polymer, believe it or not. So this is the structure for it. It's used for polyester fiber. So if you're wearing a polyester, polyester shorts I'm wearing today, that's probably made of this PETE. They're recyclable. And it has a density of about 1.58 grams per centimeter cubed. Do you remember what the density of water is? 1. So this is 58% more dense than water. So this stuff should sink in water because more dense things sink, less dense things float. So that makes this a sinker in water. Now in our lab, we're going to use water, which you'll just get out of the tap. We're also going to use salt water. So this is a 10% salt water solution. And we're also going to use some things that you have to promise me you will not drink. This is 50% ethanol, 50% water. If this was liquor, what would we say its proof is? This would be 100 proof. Is that strong liquor? That's relatively strong, right? Don't drink it. Everybody promise won't drink it. This one here is a ratio of 10:7 between the water and the ethanol. Why the two ratios between water and ethanol? To get different densities. So the most dense is this, and then I think this is 10, or this is 1:1. So we'll go this, then water, then this, and this one 10:7. I think it's 10 parts ethanol to 7 parts water, so it's more ethanol. It's 10:7. That's going to make it 10/17 for its percentage alcohol. So this one here would be the least dense because ethanol is less dense than water. So they're different density solutions, and we're going to see what floats and what sinks. And so we can bracket the densities between here and here and determine which things they are. So that's recyclable number 1. Is it common? You betcha. When I was dumpster diving, almost everything in there was soda and water bottles. I had a grand choice of type 1s. Now, the type 1s that I brought for examples here are my wife's amino acids she takes, a bamboo extract that my wife takes, and this container. You see that there are different looks to these. What would you tell me about the actual color of plain PETE based on what you see right here? What color do you think it is? Clear, right. It's naturally clear. How do you get these?
Dye.
Yeah, you put dye or something in. So those are examples of PETE, polyethylene terephthalate, whatever. Okay, recyclable number 2. This is actually the only sample that I brought with me. You might notice, hey, look, I can't see any difference at all between these two as far as the types of material. Sure, this one's polished a little more, but they look just the same, but they're different chemicals. So the recyclable number 2 is high-density polyethylene. Ethyl means 2 carbons. So the ethylene was just, CC. So polyethylene is just a whole bunch of these. So if you draw it out, here it is. You just have C, 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 going on forever with the H's attached. It's one of your most boring polymers. It's used again in bottles and grocery bags, milk jugs, has a density of 0.95. Is that going to float or sink in water?
Going to sink. Float. It is floating because it is less than 1.
That's right. It's going to float because it's less dense than water. But just barely, because that's not very different from that of water. Then we get to number 3, PVC. PVC is actually the first polymer I became aware of, because back in high school, we were putting in a new barn. We had to put in PVC pipe. Just as an aside, that PVC pipe glue, you probably shouldn't just spend half of a day in a trench with PVC glue. It makes you a little loopy. Notice what's different about polyvinyl chloride compared to polyethylene.
Each has a CL.
Yep. It just has one of the H's replaced with a CL. That's the only difference. So it's still a long chain of C's, but every other C has a CL on it. And this is used in pipes, the famous polyvinyl PVC pipes, fencing, flooring, shower curtains. You have lots of PVC around your house. But I couldn't find any of this stuff in the recycle bin. Why? Because nobody's dumping PVC pipe in there. Right? It's not used much for your household disposables. Has a density about 1.4 grams per centimeter cubed. Is that going to float or sink? That should sink in water. Then we go to number 4, low density polyethylene. Look, it's still polyethylene.
Yeah.
It's just low density. They've done something to lower the density. It's a thermocast polymer. So they've taken polyethylene and they've made low density, so it has a lower density, so it will float in water. And this is used in a lot of wash balls, lab equipment, and so on. Uh-oh. I made a mistake somewhere. Yeah. Because I have a different structure for that one that says polyethylene. Should be polypropylene. As you can tell, I copied and pasted slides, and apparently I didn't change the title here. I guess I could have looked on top where it said PP. So the polypropylene, what's different from this? Now notice this one is using the little stick structure. You have a carbon here and a carbon here, but what is attached to one of those carbons? Well, one has one carbon, one has one hydrogen, one has two hydrogens. The one that has only one hydrogen has, we call that a methyl group. CH3 is a methyl group. You add one more H, it's methane. So it has a methyl group on one of them. So once again, this is just like polyethylene or polyvinyl chloride, except for instead of having an H there, you now have a methane group on it. And it has a density, well, that's a lower density. That's definitely going to float in water. Used in auto parts and dishes. 6, polystyrene. Do you guys use polystyrene ever? Styrofoam is polystyrene. So if you look at this, yes it is. If you look at this, it says on it 6PS, polystyrene. This is nothing like, let's see, I don't have an example of polystyrene, but it's nothing like the polystyrene you're going to have for your test because this is puffed up with air.
Can you recycle that?
Can you recycle it is a good question. Yes, it's recyclable. It's got the mark on it, means it's recyclable. Will people actually recycle it? The answer is probably no.
Because we don't know.
Because of the cost of recycling makes it not worth it. So what often happens is you put that in the recycle bin. Even when they say, we recycle everything, they will just take that and compress it and take it to the landfill rather than actually recycling it. Which is kind of, makes you feel bad because you've got that sense of smug. I recycled. And what you don't know is I sent it to the recycling plant who then dumped it in the landfill. At my former employer, Pacific Union College, just after I left, they got a compressor to compress the styrofoam. They'd been collecting styrofoam in the cafeteria for a couple of years and then throwing it away. The students didn't know. They thought that they were recycling. And then they got this compressor to compress it so they could bale it. And guy was working on it alone and fell in. And it did 3 compression cycles. And he did not survive, yeah.
Why did we never hear about this?
Well, you would have been probably 3 at the time. I've been here for a long time. No, actually, it happened around 2004, 2005. Go, Brittany. Okay, so polystyrene, that density, about the density of water. So polystyrene would be about neutrally buoyant in water. Might sink, might float. Styrofoam, it's foam because they've just blown a bunch of air into it. What's that going to do to the density if you blow a bunch of air into it? It's going to lessen it, so it will definitely float. Styrofoam, we use it in cups because air is a very poor conductor. Remember we talked about conductors and insulators? Air is a very, very poor conductor, and so you puff it up with air, and now it's a good insulator. And last but not least, other. One of your samples here is in the group other. So while your actual sheet only has places for 5 things, we have 6. And so you'll have to add one more column on the first page where it has you identify the materials. And the one that's other, well, you'll just have to see what happens when you go through the different tests. So what are we going to do for, by the way, examples of 5. What was 5 again? I think that was the polypropylene, yeah. Here's examples. Whoops, this is an example of 2. I have a huge range of examples of material 5, polypropylene. You can see they look very different. You can make your plastics look lots of different ways. You make it thicker and thinner. These containers are the actual containers that I used for the samples. This one here, I used everything in my sample, so I didn't have anything to show you. So what you're going to do in this lab, and as you might guess, the lab is really quick. You're going to come up and you're going to take a sample. So for instance, I'm going to take sample A, and I want you to do every single test. I know the lab instructions say, how can you optimize this to take the least amount of time? These tests take so little time. I don't think we really need to worry about optimizing. So I want you to do every test and fill out that paper that Alex passed out. So I'm going to put water in here.
So do we not have to do the lab page?
The what?
Do we have to do this one too? Or not do it?
Yeah, you have to do that.
Okay.
This here is an additional page. Now, to test if this floats or sinks, I don't just drop it on the top. If you just drop it on the top, everything's going to float because we have this thing called surface tension. It's the reason, like, water striders can stand on top of the water. They're not floating, they have surface tension that's holding them up. So you actually have to take it and force it down, and if it floats back up, then it floated. If it stays down, then it sunk. So this one here, it floated back up to the top. And so then I would mark in here for sample A. The first column tells you the sample, so put A, B, C, D, E, F in the first column. And then for sample A, I say, hey, it floated. Of course, you need to do your own. And then I'm ready to move on. I don't want to have huge amounts of all these things. So start with, somebody pour a cup of one of these, cup of another, and label on the cup which one it is. Like if it's sodium chloride, you just put NaCl on the cup. If it's one of the 2 alcohols, either put 1 to 1 or 10 to 7. And then do all of them in the one you have in your hand. When you bring it out, you just put it back here. And, so you test it all with that one. And then put the one you started with back up here so somebody else can take that sample or that fluid and do their experiment with the same fluid.